Hi, good morning. Welcome to the revision lesson. We are dealing with the April 2021 exam paper. So this is the latest exam paper. The next one will be it's supposed to be in around July, August. So now, the first question is partial differentiation, okay, which I've uploaded a video yesterday on partial differentiation. You can have a look at that. This is the exam question. Right, so we're given z is equal to a to the power 3x minus 2y. Differentiate z with respect to x partially. Okay, so what do we need to remember here? We need to remember that if y is equal to k times a to the power f of x, so going back to our n5 work, k times a to the power f of x, then your derivative will be k times a to the power f of x times ln a times f prime x. You should know this, okay? So this is the derivative of your exponential function. So the derivative here, a to the power 3x minus 2y, will be a to the power 3x minus 2y times ln of the base times ln a times the derivative with respect partially with respect to x. So the derivative of 3x will be 3, the derivative of y will be 0. Right, that is your partial differentiation. The only part that's a bit different is the ending part. The rest is the same. When you differentiate with respect to x, treat the variable y as a constant. Right, so yeah, that was the first one. If you want to, you can simplify, but it's unnecessary here. Yeah? So this will become just 3 ln a times a to the power 3x minus 2y. But you can leave it like that, it's fine. Okay. The next question there, let's deal with the next one.
So, if we were differentiating with respect to y,
if we were differentiating with respect to y, then x will be regarded as a constant. Yes. So partial differentiation, when you differentiate with respect to x, you treat any other variable, whether it's y, whether it's z, whether it's p or whatever, you treat it as a number. So the derivative of, you imagine y as like 1 or 2, so you know what I mean? This is, you treat it as a number. So the next one, 1.1.2 d squared z all over dy dx. Alright, so how do we write this out? Now, when you have it written in this form, what you need to do first is, first of all, you identify this is on the left, this is on the right. Okay? So what's on the right must be done first, what's on the left will be done second. But the way you write it out is important. So what have we done? We have found dz over dx partially, and now what we're going to do is we're going to differentiate this with respect to y. Now you can see the dy dx here. Can you see that? So what have we done? We have found exactly your question now. We're going to be dealing with it. So this is dz over dx. Substitute. What was dz over dx? Don't just go and write it down and work it out. Learn how to write it down properly, then you won't make a mistake. dz over dx is what we just found, which is 3 ln a times a to the power 3x minus 2y. So now I'm going to differentiate this with respect to y. So I'm going to treat x as a constant. I'm going to be using the same formula. The only difference is at the end. Okay, so this is still an exponential function. K is 3 ln a now. Your constant k is 3 ln a, and this is a to the power f of x here. So when you differentiate it, it's going to be 3 3x minus 2y times ln of the base, your base is still a here, times now is the last part. Now we are differentiating 3x minus 2y partially with respect to y. So I will treat x as a constant. That means the derivative of 3x is 0. The derivative of minus 2y will be minus 2. Simple. Okay. But obviously you must know your rules from M5. Do not rely on the formula sheet for differentiation. Alright, so you don't have to go and simplify, but if you want to minus 2 times 3, that will be minus 6 ln a squared times a to the power 3x minus. You don't have to go and simplify that much, but the fact is ln a times ln a is ln a all squared. And that was 1.1.2. Alright, the next question, 1.2. Given the parametric equations, you remember the parametric equations from chapter 6 when we have those two equations, we have to differentiate it. So x is equal to 1 plus 1 divided by 1 plus 2t, y is equal to 1 plus 2t. Calculate in terms of t, dy over dx. And then the second one will be the second derivative. Alright, so now, what do we have? Let's write it down. So we have x is equal to 1 divided by 1 plus 2t. And then we got y is equal to 1 plus 2t. So now I have x in terms of t, and I got y in terms of t. So I want dy over dx. There's no dy over dx here, it's just x and t. So what we can find first is dx over dt. Now, how would we will differentiate x with respect to 2, we'll find dx over dt. Then we will find dy over dt. Then we will multiply it, and then we will get our dy over dx, you will see. Right, now, I need to differentiate this. This is a fraction. If I do it as it is, I will be using the quotient rule. I do not want to use a quotient rule, so let me rearrange this here. Let me write it as 1 plus 2t to the power minus 1, because the chain rule is simple to use. So now, I'm going to go dx over dt. I'm differentiating x with respect to t, chain rule, so that's going to be 1 times minus 1, which is minus 1. Then I got my 1 plus 2t minus 1 will give me minus 2. The chain rule, you deal with the power first, multiplied by times. Now you will differentiate what's on the inside. The derivative of 1 is 0 plus the derivative of 2t is 2. So that is my dx over dt, which becomes minus 2t all divided by 1 plus 2t all squared, if I have to simplify it. Yes?
I think I made a mistake there. You said 0 plus 2t, and the derivative of 2t is 2.
Oh, sorry. My mistake here. The derivative of 2t, yes, my mistake here is 2 here. So that becomes minus 2 all over 1 plus 2t all squared. Lucky you're paying attention. Right, so the derivative of 2t was 2, that's a chain rule. So here, dy over dt, the derivative of 1 is 0, the derivative of 2t is 2. Right, so now we have dy over dt, and then we have dx over dt. What do we want to find? We need to find dy over dx. So now let's write that down. So dy over dx is what we want. But what we have is dy over dt and dt over dx. How can we deal with this? Notice dy is a numerator, dx is a denominator here. So this equation here, dy is in the numerator, but this one, dx, is also in the numerator. So, yes?
So then dx over dt is equal Why did you say negative 1 minus 1? There.
Oh yeah.
Yes.
Oh yeah, okay, so, but you understand how I got to this step.
Yes, then.
Right, so remember, if you have a power which is a number, you have to use the chain rule. So the chain rule is, remember, let me just write down, if you have y, k, f of x to the power n, then your derivative is going to be k times n f of x to the power n minus 1 multiplied by f prime x. That is the chain rule. Okay, so the question here was, why did we do this? Because we have to multiply k times n, so that's going to be 1 times minus 1, which is minus 1. There's your f of x, in this case f of t, and then n minus 1, so that's going to be minus 1, which is minus 2, times the derivative f prime. The derivative of 1 is 0, the derivative of 2t is 2. Right, so this is the chain rule. Now, dy over dx is equal to dy over dt multiplied by, now we won't go dx over dt, we'll swap it, we'll invert it. Instead of dx over dt, we'll write down dt over dx. Check, dt and dt cancel, left hand side is equal to the right hand side. Now look, I've got dy on the top, dy on the top, dx in the bottom, dx in the bottom. So, what is my dy over dt? My dy over dt is 2 multiplied by dt over dx. Now remember, this is dx over dt. So that's dt over dx. That means I must swap numerator and denominator. Okay. So that's going to be 2 times dt over dx. It will be 1 plus 2t all squared, all divided by minus 2. So what happens here? 2 and 2 cancel, I end up with minus 1 plus 2t all squared. That's all. Right, so that is my dy over dx. That is the answer to this one. Alright, now we move to the second derivative. Right, our second derivative. So this was first derivative. And this is your second derivative. D squared y over dx squared. So now how do we write this out? Okay. So, d squared y over dx squared is the same as d over dx of dy dx. Right, that is our second derivative. D over dx of dy dx. That's the second derivative. You can see d and d will give you the d squared dx. Dx is dx all squared. Now, what is dy over dx? Dy over dx is what we just found here. You can see that. So my dy over dx is minus 1 plus 2t all squared. We got a problem now. This is the variable t, but we need to, this is d over dx. That means differentiate this with respect to x. Now, we use a simple trick, implicit differentiation. Okay, if you remember, right, what did we do with implicit differentiation? So now, let me write it down here. We got d over dx. So now, d over dx is the same as d over dt multiplied by dt over dx. So use a simple trick, implicit. Alright, so look at this here. D over dt times dt over dx. Dt and dt cancel, so I've got d on the top, dx in the bottom. Perfect. You can see that? That's exactly what we're going to do here. That's how we deal with our parametric equations. So now that will enable me to differentiate with respect to t now. Can you see that? So this will be d over dt multiplied by dt over dx. Does it work out? Yes, it comes back to the same thing here. You can see that. What we have inside here is minus 1 plus 2t all squared. So what does that mean now? It means I need to differentiate this with respect to t, and then I need to multiply the result by dt over dx, which I already found. Now there's my dt over dx. Here's my dx over dt. We swap it. So if I differentiate this, I need to use the chain rule again because I have a power which is a number. Okay. So now that's going to be minus 1 times 2, which is going to be minus 2, 1 plus 2t. 2 minus 1 is 1 times the derivative of 1, which is 0, plus the derivative of 2t, which is 2. I mustn't write down 2t, I made a mistake there before. So the derivative of 2t is 2 multiplied by dt. So that's done. The main job is done. It's just multiplied by dt over dx. Where's my dt? This is dx over dt. dt over dx is going to be 1 plus 2t all squared divided by negative 2. You can see that? Now, I'm going to simplify this. Alright. So I can see that 2 and 2 will cancel. Negative divided by negative is a positive. I'm left with just the 2 there. And 1 plus 2t times 1 plus 2t squared will be 1 plus 2t to the power 3. There's nothing more we need to do to simplify, and this is our d squared y over dx squared, second derivative. Right, so now question 2, integration techniques. This is the first one that we got here. So we need to integrate sine to the power 3 multiplied by 1 minus sine squared. Right, so now, what can we do here? If we remove the brackets, then, so removing the brackets, then you're going to have the integral of sine to the power 3 of 2x dx minus the integral of sine to the power 3 plus 2, which is 5 of 2x dx, which is okay, but now you've got 2 problems to deal with. You have to deal with this. This is 2. Now we're separating them into 2 terms. That means we know the rules, split the odd power, square identity, we must do it here. We got no time to deal with 2 problems in the exam. So let's see. So can we deal with it as it is? Okay, as it is. Without. So now this is 2 problems, which is not advisable. Now let's see. Can we simplify this as it is here? 1 minus sine squared from our square identities. 1 minus sine squared can be written as cos squared. Now, it's our normal powers of sine and cos problem. We identify the odd power always. When you're dealing with sine multiplied by cos, if you have an even power and an odd power, identify the odd power, split up the odd power. So I'm going to split this up. That's going to be sine squared times sine. Right, sine squared times sine. Now, this is multiplied by cos squared. So what what do we do after splitting our odd power? We use our square identity. It's just a method to follow. You can do this very fast. Right, so sine squared can be changed to 1 minus cos squared. What do I do after this? Multiply my like terms within the brackets. Keep the exact derivative or the unlike term out of the brackets because we want to use u substitution or inspection. So now, that's going to be 1 times cos squared, which is cos squared. Cos squared times cos squared will be cos to the power 4. We now have a situation where we have exact derivatives. Okay, if you want to, let me just do the u substitution here because most of you will be using u substitution. You can see the derivative of cos is going to be minus sine, it will cancel. So if I let u equal to cos, then du over dx, the derivative of cos will be minus sine 2x times the derivative of 2x, which is 2, make dx the subject of the formula, and that will be du divided by minus 2 sine 2x. This is u substitution. Takes long, but let's do it. So now, this becomes u squared because u is cos 2x, so that's u squared minus u to the power 4 times sine 2x, and dx is du divided by minus 2 sine 2x. You can see the exact derivative cancels, sine and sine will cancel. So what do we end up with? Minus 1 over 2, the integral of just u squared minus u to the power 4 du. And now we integrate with respect to u. So when I integrate u squared, that will be u to the power 3 over 3, u to the power 5 over 5. This is a simple thing to do, it's just a method to remember. So now that's going to be minus 1 over 2. Don't forget to substitute back for u in your final answer. Don't forget to substitute back for u. What was u? U was cos 2x. You do not have to multiply out, it's unnecessary and pointless. Leave your answer as it is. Right, the next question here, how many marks was this? 4 marks. So this was 5. This is 4. Now, we got 10 multiplied by sec. Let's see what can we do here. If I have to go and split up 10 into 10 and 10 squared, then 10 squared can be written as sec squared minus 1. Then I'm just thinking, now this is sec to the power 4, it might give us a problem. Okay, so let's try and simplify first. Let's see what we can simplify, if possible here. Right, so here, sine to the 10 to the power 3, I can write it as maybe sine to the power 3 all over cos to the power 3. Let's see what happens. Okay, if it doesn't work, we can always use a different technique. So 10 is sine over cos, and then sec to the power 4 is 1 over cos to the power 4. Sec to the power 4 is 1 over cos to the power 4. Right, so now here, this is going to be sine to the power 3 all divided by cos. Now here we are multiplying cos to the power 3 times cos to the power 4. when I multiply and the bases are the same, I will add the exponents 3 plus 4, that will give me 7. Okay. So now, it seems like I can make this a sine times cos problem. Okay, so what do I mean? That's going to be sine to the power 3 times cos 3x to the power negative 7. Cos 3x to the power negative 7. So if you compare these two here now, from here, I'm going to be using the same technique now. It's a sine times cos problem, exact derivative, odd power. If I have an odd power, split the odd power. Okay, so that's going to be sine 3x times sine squared 3x times cos 3x to the power minus 7. And then what am I going to do? I'm just following the same procedure. Split the odd power, square identity next. You can see what happens there. Sine squared is the same as 1 minus cos squared times cos 3x to the power minus 7. It's just a technique, nothing difficult from here. It just takes long to write down. What do I do? Multiply the like terms all within brackets. 1 times this will be cos to the power minus 7 of 3x minus cos squared times cos to the power minus 7 will be cos. Be careful here, when you are multiplying and the bases are the same, there's your base here. But this is a 2 minus 7, it should be minus 5. You add the exponents, that's exponent dx. And now we can use the same technique here. It's exact derivatives, let u equal to cos 3x du over dx. The derivative of cos is going to be minus sine 3x times 3. And then you make dx the subject of the formula. Okay. So now I got my sine cubed, sine to the power 3, sine of 3x. In place, wherever I see cos, I'm replacing it with u. So this is going to be u to the power minus 7, u to the power minus 5. And then dx is du divided by minus 3 sine 3x. You can see it's the same type of example, yeah? That's going to be minus 1 over 3 u to the power minus 7 u to the power minus 5 du. And now I can integrate with respect to u. U to the power minus 7, so that minus 7 plus 1, that's going to be minus 6, minus 6, that's going to be minus 4 plus c. Now I can substitute back for u. What was u? U was cos 3x you can simplify this further, but it's unnecessary. The fact is you've integrated, and that's that. If you want to simplify this further, let me just do it for the sake of, if you want to know how to simplify. So that's going to be a minus 1 over 3. So cos to the power minus 6. If I got cos to the power minus 6 of 3x, it's the same as 1 over cos to the power positive 6 of 3x. And 1 over cos is the same as sec. Okay, unnecessary in the exam, but just for your understanding, it's possible to do that. So that's going to be minus 1 over 6, and this will become sec to the power 6 of 3x. Remember here, a negative, that's how I got a positive 1 over 4 there. Plus 1 over 4, and 1 over cos to the power 4 is sec to the power 4 of 3x plus c. And that was this example. Alright, our next question, 2.3. Let's see, how many marks was this here? I think it was 4. Right? This was also 4. Now, this is multiplication. What's being multiplied here? What's being multiplied is, we've got our x plus 1 all squared, and it's being multiplied by ln of x plus 1 all squared. So if it is multiplication, the first thing you check for is one an exact derivative of the other? What does that mean? If I differentiate this, is that the answer to this here? Obviously not. If I differentiate this here, will that be the answer? No, it's not an exact derivative. Okay. Now, if it's not exact derivatives, then it's integration by parts. Okay. So integration by parts. The formula, we're going to have f of x times g of x minus the integral of g of x multiplied by f prime x. Okay. So integration by parts, priority list. Which is f of x in our priority lists? Is it going to be ln or is it going to be x plus 1 all squared? Which one is number 1? Number 1 is inverse. Number 2 is your log function. So this is number 2. Number 3 is your powers of your polynomials, your powers of x there. So therefore this is my f of x. And this will be g prime x. Okay, so now f prime x, the formula requires f prime x and g of x. Okay, we only have f of x, so let's find f prime x. So how do we differentiate this? If y is equal to k ln f of x, to differentiate, it's going to be f prime x all divided by f of x. You must have this in your head. Okay, the differentiation formulas. So f of x here is x plus 1 all squared. Okay, so now if I differentiate this, I'm going to use the chain rule for this here. So that's going to be 1 times 2 there, which is going to be 2 x plus 1, 2 minus 1, which is 1. So that is my numerator, all divided by f of x, which is x plus 1, all squared. Clear with that? F prime x divided by f of x. So therefore, the answer is going to be 2 all divided by x plus 1. You can see, obviously, x plus 1 will cancel that. So this is my f prime x. What about g of x? To get g of x, well, let me just do it here. So I know my g prime x is equal to x plus 1 all squared. I need to get g of x. That means I need to integrate to that there. Right, so to get g of x, I'm going to integrate x plus 1 all squared there. So I'm going to integrate this. Now, how do I integrate x plus 1 all squared? This is of the type k f of x to the power n times f prime x dx That's exactly what this standard form is. So when you integrate it, I'm using the method of inspection. So that's going to be n plus 1 over n plus 1 plus c. There's no time to do U substitution. So this is going to be, first you check the derivative of x plus 1 is 1. It's an exact derivative. So that's going to be x plus 1 all raised to the power 3 over 3. You don't have to put down plus c. Now we have all the information that we need. We have f of x. We have f prime x. So we got this part, we got that part, and we got that. Those are the three things to substitute here. Right. So now, what is my f of x? F of x is limit of x plus 1 all squared. G of x, there's my g of x here, which is times x plus 1 to the power 3 over 3 minus the integral. Whatever you write, it's the same g of x here. You can see that. So that's going to be x plus 1 to the power 3 over 3 times f prime x. What is my f prime x? I just worked it out here. It is 2 all divided by x plus 1 with respect to x. And now it's a simple thing to do. You can see that. So this is going to be my ln x plus 1 all squared times x plus 1 to the power 3 over 3. Here my constant is 2 over 3. So that's minus 2 over 3. And now x plus 1 to the power 3 divided by x plus 1 to the power 1. When you are dividing, this is exponent laws here. You write down the base once. 3 minus 1 will give you 2. Simplify it. It simplifies to almost the same thing. In fact, there's a gem. You can see that. So now all we have to do is integrate and we're done. So that's going to be ln x plus 1 all squared, and that's going to be x plus 1 to the power 3 all over 3 minus 2 over 3. I'm dealing with f of x, which is x plus 1 f prime x, exact derivative. We do it by inspection, so that's going to be x plus 1, 2 plus 1, that will be 3 over 3, and we're done now. So that will be plus c. So that's my 1 over 3 ln x plus 1 all squared times x plus 1 to the power 3 minus 2 over 9, and that's going to be x plus 1 to the power 3 plus c. So the examples here in this April 2021 paper, they take quite long to work out. You must know your work here. Let's move on to the next one. Alright, so we now deal with integration by completing the square, which is a common problem. Right, completing the square. Let's see this one. So let's write it down. We are completing the square. So what am I dealing with? I have minus x squared minus 3x plus 9 over 4. I need to complete the square. So step number 1 for completing the square. The coefficient of x squared must be positive 1. If it is not positive 1, you will take out that number as a common factor. So this is not positive 1, so therefore you will take out your negative 1 as a common factor. There's no dividing it. You take out as a common factor. Okay. So if I take out minus 1, I'm left with x squared. If I take out minus 3x, if I take out minus 1, basically all the signs will change. Right, so the negative becomes positive, negative becomes positive again, and the positive will become negative. So you check. multiply. Negative times positive, negative. There, negative, positive. Right, now you make sure that this is 100% correct. So now I've got my x squared plus 3x. And now you copy down the first two terms. You will always write down plus half the coefficient of x squared minus half the coefficient of x squared. And then I have my minus 9 over 4. So you are inserting always plus minus half the coefficient of x all squared. So what is the coefficient of x here? The coefficient of x is 3. So half the coefficient of x means take that number, divide by 2. That's what it means. So that's going to be 3 over 2, 3 over 2. Now, you will count the first 3 terms and you will factorize it in one step. Okay, so that will be there, put your square, and this will be x, that will be plus 3 over 2, and then we square it. Right, so now, here, so remember this has been factorized in one step. Integration by completing the square, I've done many examples, I've got about 3 videos on this, so you can always check. Right, so now here I can work this out. So this will be minus 9 over 4 minus 9 over 4 there. So I'm squaring 3 squared is 9, 2 squared is 4. So now I've got my minus 1 and that's x plus 3 over 2 all squared. If I work this out, that's going to be minus 18 over 4. And now I can multiply my negative. Remember the negative that I took out? You will multiply the negative back inside there. So that becomes minus x plus 3 over 2 all squared. A negative times a negative is a positive 18 over 4, which can be simplified further. 18 divided by 2 is 9, 4 divided by 2 is 2. So that can be simplified to 9 over 2. Now, you know that there is no formula that will start with a negative. Okay, there is no formula that starts with a negative. Always a positive. So what should we do? We should swap this. So that becomes 9 over 2 minus x plus 3 over 2 all squared. And now substitute it straight into the question. So you're going to substitute it. So that is 1 all divided by the square root there. And we just work this out. So that's 9 over 2, which is 3 over, let me just leave it as it is first. 9 over 2 minus x plus 3 over 2 all squared. Now, you should recognize this is a common one that we've been using. So what are we dealing with here? We are dealing with 1 over the square root of a squared minus b squared x squared, which is 1 over b times inverse sine bx over a plus c. That is your trig substitution. So I need to write this as a squared, there b squared, x squared. So one more thing to do here. So that's going to be the square root there, and 9 over 2 can be written as 3 over square root 2 all squared. Because 3 squared is 9, square root 2 squared is 2. Okay. Minus 1 squared times x plus 3 over 2 all squared. You will write this as 1 because we need b there in front. Okay. So now it's clear. My a is 3 over root 2. My b is 1. And my x is represented as x plus 3 over 2. Do your substitution and then you're done. So this is equal to 1 over b, which is just 1 over 1, times inverse sine bx, so that's b times x plus 3 over 2, all divided by a, which is 3 divided by square root 2 plus c. You're done. I'm just going to simplify this further. Okay, I'm going to simplify this further. From here, I'm just going to simplify this. But the fact is, we've integrated. We deserve full marks at the stage here. But for your understanding now, this can be simplified further. So x plus 3 over 2, all divided by 3 root 2 is the same as 2x plus 3 over 2 times square root 2 over 3. Follow what happened there? Fraction divided by fraction, inverted multiply. So this can be written as 2x plus 3 all over 3 root 2. Okay, I've simplified this here. I notice there's a 2 here, there's a 2 there, there's a 1 there, there's a half. When I'm dividing, I subtract the exponents, I went 1 minus half. Right, so that's going to be inverse sine of 2x plus 3 all over 3 root 2 plus c. Simplified. So this is simplified. Right, now your calculator will not simplify this the way that I did it. The calculator is going to give you a rationalized denominator. So what did I do here? I got the square root 2, 2 to the power half, 2 to the power 1. So 1 minus half is half. That's how the square root 2 came in the denominator. Right, so we move on to the next question. Alright, so the next one, 2.5, is only 1 mark. That means it has to be simple. There's more than one way to deal with it. Okay, you know that there is a formula for sine squared, there's a formula for cos squared to change it. Okay, but now, what you notice here from your double angle formulas now, your double angle formulas, we know that cos 2x is equal to cos squared minus sine squared. Right. Cos 2x is equal to cos squared minus sine squared. Now, okay, now you must be able to apply this formula. Don't only think that there's a formula for cos 2x. There's a formula for cos 4x, for cos 8x, for cos 1000x. This is a formula. Basically, this is an identity. Cos 2x is equal to cos squared minus sine squared. Right, a double angle identity. So, if I replace x on the right hand side, okay, if I let x equal to 2x, that means I'm doubling that. Wherever I see x, I'm going to double it now. So therefore, I'm going to have cos squared. I'm replacing x with 2x, so that becomes a 2x, and that becomes a 2x. Now, whatever I do on the right hand side, I must do on the left hand side. So this becomes cos of 2. Now notice this is 2x. But what is x being replaced with? 2x. You clear with that? So it's going to be 2 times my 2x. So now 2 times 2x will be 4x. Right. So you can work out anything from here. I can ask you to work out cos of 1 million x. You can work it out. Right. The main thing is now you understand how to do it. All you do is whatever you do on the right, you do on the left. Now, This is not cos squared minus sine squared. Can you see that? So what is the trick? Simple thing to do. You must know your signs without a calculator. Then you will be able to manipulate this one time. So I'll take out my negative. If I take out a negative from these two terms, this becomes a minus sine squared. This becomes a positive cos squared. Clear with that? Now, what do I have? I have cos squared 2x minus sine squared 2x. Cos squared 2x minus sine squared 2x, which is equal to cos 4x. Simplified, you can see that. So this is minus cos 4x. And now it's a simple thing to do. We're just going to integrate minus cos 4x, which is going to be minus sine 4x. This minus was already here, all divided by 4, plus c, and you're done. Now, let me just redo for some of you that may have done it the other way. So, what happens if you use the other formulas? So, what happens if you did it differently? So, remember that sine squared bx is the same as half into 1 minus cos 2bx, and cos squared bx is half, and that becomes 1 plus cos 2bx. So if you wanted to use these formulas, you can. So what do I mean? Let's redo. So 2.5, I got sine squared 2x minus cos squared 2x dx. So if you went this route, and I got sine squared 2x, my b is 2 there. Can you see that? So this can be written as half. So there's my half. 1 minus cos 2b. So that 2 times 2 will be 4. Minus half into 1 plus cos. This is the only difference is the plus sign there. Can you see that? So it's going to be 1 plus cos of 2b. Whatever b is 2. So 2 times 2 will give me 4. So you could have done it this way. So now what happens here? Half times 1 is half minus half cos 4x, minus half times 1 is minus half times cos is going to be minus half cos 4x. What do you notice now? What do you notice here? You got a plus half, a minus half, 0. So I got minus half cos, minus half cos. I can add these two up. They are like terms. Minus 1 over 2, minus 1 over 2. What is that equal to? You got minus 1 over 2, minus 1 over 2, which is minus 2 over 2, which is equal to minus 1. So therefore this is equal to minus cos 4x, which is the same thing. Now look at minus cos 4x. Minus cos 4x, just that it takes longer to do it this way. Now we can integrate minus cos 4x, which is going to be minus sine 4x all over 4 plus c. Too much of work for 1 mark. We need to be fast in the N6 exam. Look for the fastest way to solve the problem. But this is still correct. Let's move on to the next one. Alright, so question 3, partial fractions. Okay. These ones take normally long to work out, but let's see what we're going to do now. Now, first of all, first thing to check for is, do we go straight and apply partial fractions, or do we do long division? That is the question you ask yourself. Now, the answer to that is, you will first check if the numerator is of a lower degree than the denominator. If the numerator is of a lower degree, that means if the top is smaller than the bottom, then you apply partial fractions. If the answer is no, then you will use long division first. Now let's check. What is the degree of the numerator? Highest power is 2. So the numerator is of second degree. Denominator, what is the degree of the denominator? We've got 2 plus 1 plus 1. So that's going to give me 4. Alright, so the degree of the denominator is 4. That means top is 2, bottom is 4. It's fine. We will apply partial fractions. Okay, so now let's do it. So I got my 3x squared minus 6x minus 1 all over x squared plus 1, x plus 1, and then x minus 1. Right, so now let's deal with this. So first factor is x squared plus 1, which cannot be factorized. It must have two constants there because it has a power 2. So this can be written as ax plus b all over x squared plus 1. You must have the x there, right? Because this is an x squared, always. Now, plus, then we got c all over x plus 1, and then the last one is d all over x minus 1. Alright, now I'm going to multiply by this denominator on both sides. I'm going to do it in one step. I'm not showing you every single step. You're going to check all steps, and you need to watch my partial fractions video where I do it in detail. So I'm going to multiply on both sides here. So I got 3x squared minus 6x minus 1. Then I have my ax plus b. So the trick is, this is how I'm thinking now, right? How do you do this in one step? All you're doing is x squared plus 1 is going to cancel with x squared plus 1, and what remains is x plus 1, x minus 1. You can do this in one step also. So that's going to be x plus 1, x minus. This is a shortcut. Okay. Plus c. Now, x plus 1 will cancel with x plus 1. So what remains is x squared plus 1 times x minus 1. So that's x squared plus 1 times x minus 1. And then we got plus d, so that's going to be plus d. X minus 1 will cancel with x minus 1. So what's left is x squared plus 1 times x plus 1. You're clear with that? Right, now from here, there are two options. One is using the method of inspection, and the other one is, not inspection, I mean substitution or equating coefficients. Okay, so it's substitution or equating coefficients. Now, equating coefficients is the longer way. Substitution is a shorter way most of the time. Now, clearly, I can say now that I can substitute a 1. Then I can also substitute 1 here, minus 1 there. So let's do substitution now. We can definitely work out some things here. Let me start with 1. Right, so I can let x equal to 1. Right, you double check me there on the left hand side for all the values there. So if I substitute 1, I'm going to get 3 minus 6, which is minus 3, minus 1, which is minus 4. Here, when I substitute 1, that's a 0 straight. Because 1 minus 1 is 0. 0 times everything is 0 there. When I substitute 1 here, 0 straight. Because 0 times anything is 0. Here, 1 squared is 1. 1 plus 1 is 2. 1 plus 1 is 2. 2 times 2 is 4. So 4 times d is 4d. So therefore, d is going to equal to minus 4 divided by 4 is equal to minus 1. In a few seconds we got that answer, you can say that. Next one. Let x equal to minus 1 this time. Let's put minus 1 in. So when I let x equal to minus 1 squared is 1. 1 times 3 is 3. Minus 1 times minus 6 is 6. So that means 3 plus 6 is 9. Minus 1, which is 8. Clear with that? 8. Substituting minus 1 here. Minus 1 plus 1, 0. 0 times anything? 0 straight to there. Here is where we're going to get an answer now. Minus 1. Minus 1 is minus 2. Minus 1 squared is 1 plus 1 is 2. So 2 times, 2 times minus 2, which is going to be minus 4c. You're clear with that? Okay, so again, minus 1 is minus 2. That's a minus 2. Minus 1 squared is 1. 1 plus 1 is 2. 2 times minus 2 is minus 4. Okay, here. Minus 1 plus 1 is 0. 0 times anything? 0. So that's a plus 0. Now, I got 8 is equal to minus 4c. 8 divided by minus 4 is equal to minus 2. So c is equal to minus 2. Now, that's the next substitution. Now, there's nothing that's going to give me the answer straight. So I'm going to use 0. Okay, I'm going to let x equal to 0. Let's see what happens if we let x equal to 0. If I let x equal to 0, on the left hand side, that's a 0, that's a 0, and this is minus 1. Here, now, that's a 0, that's a 0, that's a 0. 1 times minus 1 is minus 1, times b is minus b. Here, that's a 0, that's a 0. 1 times minus 1 is minus 1, so that's minus 1c. That's a 0, that's a 0. 1 times 1 is 1 times d, which is d. Okay. Now, let's see. What do we know? What we don't know. We know d and c. We know d and c, that means we can work out b. Right, so now, minus 1 is equal to minus b minus c. What is c? Minus 2. C is minus 2. Plus d, d is minus 1. Right. Now, let's see what happens here. So, okay, if I spell the minus 1 and minus 1, that's house. So that's going to be a 2. Take it to the left. It will become minus 2. So basically I got minus 2 is equal to minus b. So therefore, b is equal to 2. All we need to find now is d. So we can substitute anything. Right, any value. We choose the easy values. I chose 0 here. And the next one, what can we substitute? Let's put 2. Let me go for 2. It's up to you what you want to substitute. Let me go for 2 on the left hand side. Check me on the left hand side. So 2 squared is 4. 4 times 3 is 12. Minus 6 times 2 is minus 12. 12 minus 12 is 0, so I end up with minus 1. Is that correct? Right. Here, 2. I'm substituting 2 now. So 2 plus 1 is 3. 2 minus 1 is 1. So that's 2 plus 1, which is 3. And this is 2 minus 1, which is 1. 3 times 1, which is 3 here. Times 2a will be 6a. And 3 times b will be 3b. Okay with that? You can double check that. Right. Here, substituting 2 again. So 2 minus 1 is 1. So that's a 1. 2 squared is 4 plus 1 is 5. 5 times 1 is 5. So that's a plus 5c. Right. Here. 2 squared is 4 plus 1 is 5. 2 plus 1 is 3. 5 times 3 is 15. So that's plus 15d. Alright. You must be fast. You working on the calculator, check what I'm doing. So that's going to be minus 1 Now, what am I looking for? I got D, I got C, I got B. I already have D. All I need to do is work out A now. So now, that's going to be 6A plus 3B plus 5C plus 15D. What is B? B is 2. What is C? Minus 2. What is D? Minus 1. Alright, so let's see what we get on the right hand side. 3 times 2 is 6, minus 10, which is minus 4, minus 15, which is minus 19. So that's going to be minus 19 plus 6a. So if I take minus 19 to the left, it becomes 19 minus 1, which is 18. So 18 is equal to 6a. That means 18 divided by 6 is equal to a. So therefore, a is equal to 3. A is equal to 3. Alright, now this is the difficult part because it takes long to work out. Alright, integration part, well, it's not that difficult. Let's see, so let's substitute now. So therefore, now we have the integral of, let me do it here. The integral of A, so that's going to be 3x plus b plus 2 all over x squared plus 1 plus the integral of c, which is minus 2 all over x plus 1, and your d here is minus 1 all over x minus 1. We are now ready to integrate. We are ready to integrate. Now, right, so the integration, you know, it's always almost the same here at the end. Okay, if you didn't realize that, I'm not sure why. Right, it's always, you know, you're dealing with this term, and that term there, especially this one. You know that, yeah, this is not an exact derivative. You need to split it up into 2 terms. So now that will be 3x all divided by x squared plus 1 dx plus 2 all divided by x squared plus 1 dx there. Well, here that's minus 2 and that's 1 over x plus 1 minus 1 over x minus 1. Alright, now here the numerator is supposed to be an exact derivative of the denominator. Let me take this 3, write it here, and show you inspection. Now, there's no time for you substitution here. You must learn inspection. Okay, the derivative of x squared is 2x, so I multiply by 1 over 2. One time we do it. Can you see that? Here, we're going to come to this one. Here, the derivative of x is 1, and sort of derivative of x is 1. The only problem is this term. So term 1, term 3, and term 4 all are of the same type. What do I mean? We are dealing with f prime x all divided by f of x, and the answer is ln absolute value of the denominator plus c. That's term 1, term 3, term 4. This term here is in the form 1 over a squared plus b squared x squared, which is the same as 1 over ab times inverse tan bx over a plus c. We are dealing with inverse tan. So what do we do with this one? There's your 2 there, let me write 1 there. A squared plus b, let's just swap this around here. Let's write it as 1 squared plus 1 squared times x squared. Same thing, x squared plus, it's the same x squared plus 1. You can see that. All I'm doing is making it a perfect match here. There's your a, there's your b, there's your x. Alright, so now we're ready to integrate. The f prime x over f of x, numerator is the derivative of the denominator, so the answer is going to be half ln absolute value of x squared plus 1. Here, this is going to be plus 2 times 1 over AB. So that's going to be 1 over 1 times 1. 1 over AB, inverse tan, bx over a, 1x over 1. Here, f prime x over f of x, that's going to be minus 2 ln of x plus 1. And here, same thing, that's going to be minus 1 ln absolute value of x minus 1. Let me just write this down in one line here. So this is going to equal to 1 over 2 ln absolute value of x squared plus 1. That's term 1. Term 2 is plus 2 times arctan or inverse tan of x. Term 3 is minus 2 ln absolute value of x plus 1. And we got minus 1 ln absolute value of x minus 1 plus c. And that's our 6 marks. Let's move on to the next one. Alright, so thanks to my students, two mistakes picked up here. That's a minus 2 there, so this is minus 2, yeah? So this is supposed to be a minus 2 here, and that's a minus there, so that becomes minus. The other one is, I forgot that there's a 3 there, so 3 times 1 over 2 is 3 over 2, so that becomes 3 over 2. Right. Yeah. So there's a 3 times 1 over 2 is 3 over 2, 3 times 1 over 2, 3 over 2, there's my minus there. The minus, I forgot to write it down. And that's basically it. Anything else? Any other problems here? Right, let me just double check first, just to make sure everything is 100% now. Yeah, so the mistake was here, sorry. That's a plus 2, that's a plus 2 there. So this stays as a plus 2, and this will be a plus 2. Sorry, okay, this one was right, but the problem here was there. Yes, so that is a plus 2 there. Anything else? So, be careful. With the signs, I'm transferring information from there to there to there to there.
I think the mistake you made is when you must separate it.
Yes. Yeah. But now it's
Because
fine.
now you do positive 2.
Yes. Right. So it's 3x. Yeah. So it's separated. There's a 2 there. Yes. Positive 2.
Negative 2.
Where's our b? Ax plus b. 3x plus 2.
3x plus 2 over x plus 2.
Yes, yes. So there's my 3x. So it's ax plus b. My a, let me just make sure my a is 3. So there's my 3x. My b is 2. So that's 3x plus 2. So when I separate it, it's going to be 3x all over x squared plus 1 plus 2 all over. Yeah. Sorry, so there's a chair. There's a chair. All over, there's a chair plus 2 all over x squared plus 1. Which step?
C is minus 2.
Oh, C.
Yes.
C is minus 2. Oh, this one, yeah.
This one. First step.
3x plus 2, so that's 3x plus 2, so there's a minus 2
First
here.
step, the first one. Look at the first one.
That's A, B, C. Oh, yeah. This one, yeah. We're talking about this one. Yeah. Minus 2, so there's my minus 2 there. And also it was incorrect here, but then it becomes correct here. I noticed there's my minus 2 there, minus 2 there, minus 2 there, minus 2, so it's fine now. Let me just double check this. So there's my 3x there, plus 2, it's fine. It's fine. Okay. Alright, so this is the second question. Partial fractions 3.2, 6 marks. Determine, is this a proper or an improper fraction? Okay, the previous one was a proper fraction. That means the numerator is smaller than the denominator. In this case, the numerator is larger than the denominator. Okay, because this is of the third degree, this is power 3, that's 2, top is larger than the bottom. So if it's equal or larger, you must divide. Okay, so now long division. So we got our x squared minus 9, and this is going to be x cubed plus 0x squared minus 10x minus 15. Okay, now step number 1, we know you can always check my partial fractions long division examples. So the rules are divide, multiply, subtract, bring down the remaining terms. Okay, so divide, multiply, subtract, bring down. What are we dividing? It's going to be x to the power 3 divided by x squared. So x to the power 3 divided by x squared is x. Multiply now. So there's going to be x times x squared, which is x to the power 3. X times minus 9 is minus 9x. Right, that is my multiplication. Divide, multiply, subtract now. Okay, what are we subtracting? Top minus bottom. X cubed minus x cubed, 0. Okay. Minus 10x minus 9x, that becomes minus 10x plus 9x, which is going to be minus 1x. You know, change the sign of the bottom term and add. If you want to do that, basically minus changes to a plus. Minus 10 plus 1 is minus 9. Sorry, minus 10 plus 9 is minus 1. So, let's divide, multiply, subtract, bring down. So you're going to bring down your minus 15. Check, is it possible for me to divide again? If I go minus x on the top divided by x squared, we're checking. You stop when you have a proper fraction. So what do I mean? You're checking again. You're going minus x on the top divided by x squared. This is a proper fraction. Do not cancel anything here. 1 is smaller than 2. It's no more. There's no more division now. Right. So you stop here. This is your remainder. Okay, this is the remainder. So therefore, we got x cubed minus 10x minus 15 all over x squared minus 9. That was the question given to us. We simplified it and it became x, which is the portion here, plus always the remainder all over the divisor. The divisor is the denominator. So that's going to be minus x minus 15 all over x squared minus 9. Okay, so this is equal. It's equivalent to that. You can check it on your calculator. You substitute a value for x in the left hand side, you'll get an answer. Substitute the same value for x and you must get the same answer there. If not, that means we made a mistake somewhere. So now we do long division so we can get this part. Now this is the part we need to simplify further now because this is going to be partial fractions. Okay. Or, yeah, they say use partial fractions, so we're going to be using, that's not the only way to do it. But, so let's take this one. So now let's apply my partial fractions. So there's a j, so I'm going to go minus x minus 15 all divided by, this is the difference of two squares here, x squared and 9 is 3 squared, so that's going to be x minus 3, x plus 3. It's an easy one. This is the one from N5. Simple partial fractions, yeah? So that's going to be A all over x minus 3 plus B all over x plus 3. What do I do next? Multiply by the factorized denominator on both sides. So I have minus x minus 15 is equal to A multiplied by x plus 3, B multiplied by x minus 3. Okay. So I'm going to use substitution. You can see I can substitute 3 and I can also substitute negative 3. So if I go, let x equal to 3 for the first time, that's going to be minus 3 minus 15, which is minus 18. 3 plus 3 is 6 times A is 6A, that's a 0. So therefore, minus 18 divided by 6 is equal to A, so therefore A is equal to minus 3. Second substitution, let x equal to minus 3 this time. If I substitute minus 3 now, I'm going to get minus minus 3, which is a 3. 3 minus 15, which is minus 12, is equal to minus 3 plus 3 is 0. Minus 3 minus 3, minus 6b. So minus 12 divided by minus 6 is equal to b. So b is equal to 2. Clear with that? So this is now equal to minus 3 all over x minus 3 plus b, which is 2 all over x plus 3. So now I need to integrate. So let me just put in my integration sign now. I need to integrate there. I need to integrate here also. Okay. So now I need to integrate x. I need to integrate minus 3 all over x minus 3. And then I need to integrate 2 all over x plus 3. So now, when I integrate x to the power 1, that's going to be 2 over 2. Here, exact derivative. You can see numerator is an exact derivative of the denominator. You know what to do here is take this minus 3, write it as 1 there, take the 2, write it as 1 there. Okay, so now the exact derivative, the numerator is an exact derivative of the denominator. So that's going to be minus 3 ln absolute value of x minus 3 plus 2 ln absolute value of x plus 3. Then we got plus c. And that was our 6 marks for this one, 3.2. Okay, let's do this. Alright, question 4. Determine the general solution of dy over dx plus y sec x is equal to x times cos x. Right, so now, standard formula. We know that dy over dx plus py is equal to q. P is a function of x, q is also a function of x. Right. So in this case, p is sec. So my p is sec x. My q is x cos x. What do we need to do? We need to find the integrating factor. The integrating factor is e to the integral of p dx. Okay. Now, let's substitute here. E to the integral of p. P is sec x. You clear with that? we need to integrate sec x. So you should be familiar with the integral of sec x. We'll be learning absolute value of sec x plus tan x. And this can be simplified further. Why? Because from your log e to the power, then f of x will always equal to f of x. This comes from your logs. Okay, that means I can simplify further here. This will equal to just the absolute value of sec x plus tan x. That's basically it. We're using the positive, so that's just sec x plus tan x. Right, it's just sec x. You don't have to worry about the absolute value, but that is the correct one. Now, once we got this, then we know that y times your integrating factor is equal to the integral of q times your integrating factor dx. That is a formula you substitute into. So it's going to be y times my integrating factor there, which is sec x plus tan x is equal to the integral of q. What is my q? It's x cos x multiplied by my integrating factor, which is sec x plus tan x dx. We need to simplify. We need to simplify the right-hand side. Okay, now I got my x cos x. Sec is the same as 1 over cos. Tan is the same as sine over cos. Alright, let's multiply. Alright, so when I multiply x cos x times 1 over cos x, cos and cos will cancel them. So I end up with just x plus x cos x times sine over cos. Cos and cos will cancel. I end up with x sine x. Okay, now here, this is straightforward, but this is integration by parts. Okay, this is integration by parts. So I'm going to integrate x with respect to x plus. In order to do this, I need to use integration by parts. So there's going to be f of x, g of x minus the integral of g of x times f prime x dx. Okay, so now integrate x to the power 1, that's x squared over 2. That is fine. We'll leave that as it is. Here, my f of x, remember integration by parts, you go to your priority list. And x is number 3, sine is number 5. So number 3 must be chosen as f of x. So therefore, f of x is x. This is going to be g prime. So when I find g, when you integrate sine, it is minus cos. So that's f times g minus the integral of g, which is minus cos, times f prime. F is x, so f prime will be 1. Now, this becomes x squared over 2. Positive times a negative, that will be minus x cos x. Negative times negative is a positive there. And when you integrate cos, the answer is a positive. Sine plus c. Left hand side, y sec x plus tan x, and this is the general solution. So this, you have to, this paper is not easy. You can see this April 2021 involves a lot of simplification here. So you better watch carefully, you better redo many times. You must redo and understand simplification involved to be ready for the next paper. See, that is 4.1. Let's do 4.2. Right, so calculate the particular solution of, we got a second order differential equation. Happens to be simple because the right hand side here is 0. Okay, you know that this is the first time I'm seeing something so simple in the exam, but it's maybe because the other examples were difficult, so maybe this one they made it easy for you. Right, so what we need to do is just work out the complementary function only because the right hand side for your particular integral is 0. So what I can do is, let's see, I can let y equal to 1, d over dx equal to m, and d over dx all squared equals to m squared. We know the right hand side is already 0. We normally make it equal to 0, but this time it is given to us as 0. So now that can be m squared minus 6m plus 12 equal to 0. We form a quadratic, factorize if it's possible, or we can use the quadratic formula. Okay. Right, so can this be factorized? Factors of 12, 4 and 3, 6 and 2, 12 and 1. This doesn't look like it can be factorized, am I right? Now, we'll use a quadratic formula. So the quadratic formula, m is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Use the quadratic formula and let's substitute. So my b is minus 6. So that's a minus 6 here. A is 1. C is 12. A is 1 again. So that becomes 6 plus or minus the square root of, that's 36 minus 48 there, which is minus 14. Minus, what is it? Minus 12. Minus 12, sorry, minus 12. Minus 12 all divided by 2. So this can be written as 6 plus or minus the square root of 12 times the square root of minus 1 over 2. So what do we do here? We will let the square root of minus 1 equal to j. These are complex roots here. So this is going to equal to 6 plus or minus the square root of 12 times the square root of minus 1, which is j, all divided by 2. So we can simplify this further. That's going to be 6 over 2 plus or minus the square root of 12 over 2j. So 6 divided by 2 is 3 plus or minus the square root of 12 over 2j. So these are complex roots here. So you got m is equal to a plus or minus b times j. So your y CF is going to equal to e to the power ax, and that's going to be a cos bx plus b sin bx. So that's going to equal to e to the power 3x, and that's going to be a cos of the square root of 12 over 2x plus b sine the square root of 12 over 2x. So basically this is the general solution. Why? Because there is no particular integral here. The right hand side is equal to 0. So this is a general solution. We now need to find the particular solution. We need to substitute values there. Alright, so now the complementary function is the general solution because particular integral is 0. It is not to integrate 0, it's just 0. Now, what do we know? When y is equal to 2, x is equal to 0. So that's my 2 there. X is equal to 0. So e to the power 0 here is 1. Okay, if I put x equal to 0 here, I know that cos of 0 is 1, so that's going to be a. And I know that sine of 0 is 0, so 0 times b is 0, so basically a is equal to 2. Straight, one time you get it. Now, what is this? dy over dx. So I know that y is equal to e to the power 3x, then it's 2 cos of square root 12 over 2x plus b sine of square root 12 over 2x. Now, dy over dx means the first derivative. So, this is multiplication. I got e to the power 3x times a function of x. That means I have to use the product rule to differentiate. So, dy over dx. The product rule is, write down the first, differentiate the second. The derivative of cos is going to be minus 2 sine square root 12 over 2x times the derivative here, which is square root 12 over 2, plus the derivative of sine, that's going to be b cos of square root 12 over 2x times the derivative here, which is square root 12 over 2. So that's write down the first, differentiate the second, plus write down the second. Differentiate the first. The derivative of e to the power 3x is e to the power 3x times 3. Right. That is the product rule. Now, dy over dx is equal to 6 plus 4 root 3. When x is equal to 0 again now, let's substitute our x equal to 0. Okay. Now, we know that e to the power 0 is 1, sine of 0 is 0, cos of 0 is 1, so I'm going to have a 0 plus b times square root 12 over 2. So that's this bracket here. That's a 1 there. So let me just repeat. E to the power 0 is 1. If I put a 0, sine of 0 is 0. If I put a 0 here, cos of this 0 here is 1. 1 times b times square root 12 over 2. That's what we get. Plus, I'm substituting 0, remember? So cos of 0 is 1 here times 2. That will be a 2. Okay. And then what else here? Sine of 0 is 0. So 0 times anything here is 0. So that's 0 there. E to the power 0 is 1 times 3 will be 3. Okay. What are we looking for? B. So I got, let's say, 6 plus 4 root 3 is equal to square root 12 over 2b plus 6. So what does that mean now? 6 and 6 will be out. 4 root 3 is equal to square root 12 over 2b. So therefore, I can work out b is equal to 4 root 3, so that's 4 times 2 is 8. Root 3 divided by root 12. 4 times 2 is 8, that's root 3 divided by root 12, which we can simplify further. Square root of 12, that's 4 times 3, which is 12. So what can I do here? Square root 3 cancels. Square root of 4 is 2. 8 divided by 2 is 4. So I got 4 there. I'm just rushing with this because my battery is going to go flat and this video is going to end. Right, so you can always double check me on the calculator. Right, so I worked out a equal to 2, b equal to 4, substitute back. So therefore, y is equal to e to the power 3x, and that's 2 cos square root 12 over 2x plus 4 sine square root 12 over 2x, and that is my particular solution. Working that out quite fast. We deal with the next question 5 the next time.